the point which we people are going to study is differential pressure sensor, and that differential pressure sensor is nothing but a delta cell type of a sensor. Now differential pressure, how we people are going to specify? If suppose I am having a two pressure P1 and P2, and we are having a U-tube manometer with us. At that time, when both the pressure P1 and P2 are equal, at that time, the level of the liquid is going to be maintained. If suppose my P1 and P2 are not equal and P1 is greater than P2, at that time, the level of the liquid may be raised somewhat like this. So over here, this H can be determined. So this is nothing but the difference that has been arrived, and a similar concept actually in capacitive type of sensor we people are using for the measurement of the pressure. So in differential pressure sensors, that is utilizing the capacitive type of principle or capacitance for the measurement of pressure that can be fruitfully incorporated. So these are nothing but these are the contents that we people are going to study in this particular lecture. After completion of this lecture, you people are able to design some of the application using differential pressure measuring device or various type of pressure sensing device, and able to elaborate the concept of uh, capacitive type of sensors that can be used for the pressure measurement. So these are the learning outcomes of this lecture. Now we have already seen what is pressure. So pressure is nothing but it is the ratio of force per unit, that is force exerted on a particular area or particular region, and can be measured in Pascal, PSI, atom, bar, torr, and its SI unit is actually pascals. So pressure is defined as a force per unit area, force divided by area. So as already I have elaborated all these concepts regarding the pressure, it can be exerted on solid, pressure can be exerted on liquid also, pressure can be exerted on some of the gases, all type of uncompressible gases also. Okay. So you are supposed to remember this particular aspect, because the similar principle is going to be used entirely in all type of pressure measuring device. Now, diaphragm plate capacitive pressure transducer. So we have seen the concept of capacitive type of pressure measuring device, and this is one of the pressure measuring device. Suppose this plate is the fixed plate and this one is the moving plate, and the normal structure is specified like this. So what is going to happen if I change the position of this particular one? If I have reduced the position or moved that particular plate to this side, my capacitance is going to change. So this change in capacitance is totally depend upon the displacement that has been given to it, or the distance between the two plates. Here the fixed plate is not going to move anywhere. However, when we people are applying a force or pressure across the moving plate, the distance between the two plates are going to change. Distance, either it will increase or either it will decrease. And depending upon the change in the distance, here the change in the capacitance will take place. So this is the basic concept for the capacitive type of sensor. So here we people are applying a pressure as an input, and that particular pressure is going to provide the change in the displacement, and that displacement will vary the capacitance, but the displacement is the function of pressure which has been applied as an input. Okay. Now application. So here we people are having the diaphragm. So diaphragm is acting as a moving plate. Diaphragm is acting as a moving plate. and this one is your stationary plate, stationary or holded condition plate. So this is not going to move. This one is the fixed one. This one is the fixed one. Over here, only diaphragm type is going to move. At the initial condition, at the initial condition, actually this diaphragm is like this. The structure of the diaphragm is like this when input pressure is not applied. When input pressure is not applied as an input to this particular casing. As soon as we apply a input pressure to this, what is going to happen? There will be a deflection, as we have seen that diaphragm is elastic type of a sensor. So due to applied pressure, whatever may be the pressure, if low pressure has been applied, the deflection generated will be less. If more pressure is applied, then the deflection generated will be less, more. Now, I will consider this particular part at the lower side. Suppose this is the diaphragm and here is my stationary plate. So this particular part is nothing but it is the distance. What is going to happen over here when we are applying a pressure? The changes we people are going to get for the maximum pressure will be like this. Means deflection has been arrived. If you observe at this point, here your distance d has been changed. Distance has been changed. Now, when distance changes, as per the definition, capacitance is the function of dA and epsilon. So, when my distance is going to change, automatically the capacitance is going to change. Okay, my capacitance is going to change. Okay, so over here, we people are going to get the variation in the capacitance due to this change in the displacement. But this capacitance, is connected to a bridge, similar to that of your Whiston bridge. But this one is the capacitance bridge. These are not the arcs; these are the capacitance actually, and depending upon the applied pressure, reference pressure is also given as an input. You can use or you cannot use also. Means it is not mandatory to use the reference pressure, but in some of the, this is nothing but your known pressure. Known pressure is applied as an input to maintain the position at the straight line. Maintain the position of the straight line at the diaphragm. So what is going to happen? When we are applying a pressure as an input to this one, deflection arises, and at this particular condition, this bridge is going to become unbalanced, representing your voltage, representing voltage. Some X volt we have got. This X volt is nothing but it is proportional to that of applied pressure. It is proportional to that of applied pressure. So the input pressure is calibrated in terms of resultant output generated across the bridge. Resultant output generated across the bridge. So stationary plate is not going to move. The only diaphragm is going to move. But this diaphragm at initial condition, when there is no deflection and our diaphragm is in this particular case, at that time, the output of the bridge is null. Output of the bridge is null. So we are not going to get any voltage output at this condition. As soon as we apply a pressure, depending on that, this bridge is going to become unbalanced, and unbalanced bridge will generate the output voltage. This output voltage is calibrated in terms of input pressure that has been applied, because that is nothing but that is the function of applied pressure, which leads to change the position of the or provide the displacement to the diaphragm. So this is the constructional detail of the diaphragm type capacitive pressure sensor, and its thorough introduction has been provided over here. So capacitance is inversely proportional to that of your displacement. Epsilon 0 and epsilon r are nothing but they are dielectric constant. So 8.854 multiplied by 10 raised to 12 farad per meter square is the epsilon 0, and ER dielectric constant. What dielectric constant we people are using, it is no. But whatever the significant point which I want to highlight over here, my C is inversely proportional to D. It means if suppose my C displacement, if suppose this particular displacement increases, capacitance will decrease. Capacitance will decrease, whereas if it decreases, capacitance will increase. So change in the voltage we are going to get in the bridge, that will also be a inverse one when we people are using the distance as an parameter, because C is inversely proportional to the displacement. However, the epsilon or area is directly proportional. So when area changes, uh, area increases, capacitance will increase. Area decreases, capacitance decreases. Similar to that of your epsilon, dielectric material increases or changes, capacitance will change. It is directly proportional to that particular parameter. So these are the structure of the capacitive type of sensors, that capacitance of the capacitor changes when the area of the plate changes or area of the plates vary. Then if the distance between the two plates varies, then the dielectric constant epsilon r, it is epsilon r, not this one, this particular one, epsilon base to r changes, and c is directly proportional to 1 by d. So only the difference is that capacitance will increase when displacement is decreased. So this is the basic of the capacitor for the pressure transducer, and the similar one is incorporated for the application purpose also. So either any one of from these three, any one can be a movable plate, and that can be utilized for the measurement of pressure. After applying pressure,